Welcome to lesson number 6, the cosine law. Now, when we're using the cosine law, it's not going to be set the same as the sine law, which is what you looked at in the last lesson. So let's consider this first question. Consider a triangle ABC, in which angle A is 36, A to B is 3 centimeters, A to C is 6 centimeters. What happens when you try to apply the sine law to determine the length of BC? Okay, so the length we're looking for is right here. That's length A. And remember, with the sine law, we're using sine A over A is equal to sine B over B is equal to sine C over C. And remember, for any question, we need 3 pieces of information. So for any triangle, we need 3 pieces of information. But when we look at this one, let's see what's going to happen here. Sine A was sine 36. Okay, so that's my first piece of information. It's sine 36. And that's over A since we're looking for side A. Sine B we didn't have, but instead we have side B. And so we have sine B over 6. And we also have a third piece of information. We have side C. So I don't have sine C, but I have this third side. Now, we can't actually solve this question because we don't have a link between any sides. There's no link between any sides in terms of our ratio and an angle. And so for this question, we're not going to be able to use the sine law. And so if you have a triangle like this, you're actually going to have to use the cosine law, which I'll show you now. Now I'm gonna kind of skip over the proof of the cosine law, but I will show you the formula that you use to solve it. So in using the cosine law, in every triangle ABC, you can solve using the cosine law, which is a squared is equal to b squared plus c squared minus 2 times b times c multiplied by cosine A. Now for this, there's also 2 other variations of this equation, and it's found down here. And so by placing AC and then BC on the x-axis, so if you were to make a triangle placed on the x-axis, you can have similar equations which can be used. And in that case, you would just for every a value, would switch with b, and the a would take the place of the c value. So it kind of just shifts. The equation just shifts over one. All right. And so if you're looking for side B, then you would use this variation. If you're looking for side C of your triangle, you would use this variation here. Okay, so both of these you should be able to manipulate on if you're given the actual cosine law, but this one and this one will not be given on your formula sheet. Only this one is on your formula sheet. All right, so make sure you know how to actually go through and manipulate to solve for B or C. Okay, so let's look at this first question. Class example number 2. Consider triangle ABC from class example number 1. So that's the first one we looked at where we were asked to use the sine law. This time we're going to use the cosine law. Determine the length of BC to the nearest tenth of a centimeter using the cosine law. So let's write our cosine law there. A squared is equal to b squared plus c squared minus 2 times bc cosine A. Okay, and so from here, all we need to do is take the information that we have and fill it into our equation. So I have side B, which is right here. I'm looking for length BC or A, and I don't have angle C or angle B. And so let's plug all this in right now. So A squared then is equal to B squared, which is 6 squared, plus C, which is 3 centimeters, plus 3 squared, and that was a 6, not a B, minus 2 times 6 times 3 times cosine of 36. Alright, and so let's plug this into our calculator and see what we get. Okay, now the first thing you need to do for any of these questions, and for any question in this unit, is quickly go into your mode and make sure that it's not on radians, but it's on degrees. So if this is what your calculator looks like right now, then you have to switch it to degrees and just press enter. The reason is, if you don't do that, it's going to give you the wrong answer every time. Okay, so let's type in what we have here. We have 6 squared plus 3 squared minus 2 times 6 times 3 cosine 36. And I get an answer of 15.8753. Alright, and so I'm gonna use this answer. So I'm just gonna, on my paper, I'm gonna round this to a squared is equal to 15.88. Okay, but when I actually take the square root of it, because I need to take the square root in order to solve for a, so the square root of 15.88 is equal to a. Rather than typing in 15.88 in my calculator, I'm going to go square root of second answer, because this is going to take all the decimal places that are currently in my answer, and it's going to take the square root of this whole number at the top. And so if I'm solving to the nearest tenth of a centimeter, I'm going to round this up to 4.0. So a is equal to 4.0, and therefore we were looking for the length. The question asked us to determine the length of BC, and so we determine that is 4.0 is equal to BC, and that is how you use the cosine law. Okay, now find the length to the nearest tenth of a centimeter of the third side of triangle PQR. If QP is equal to 1.7 centimeters, QR is equal to 3.1 centimeters, and we're looking for this side, Q. Alright, so that's going to be the third side that we need to find. Let's see here. Let's actually name what we have here in terms of R, P, Q, and R. So this is going to be P, or sorry, this is R. Down here is P, since it's across from angle P. And this is Q, since it's across from angle Q. We know that angle PQR, so if we have angle PQR, that's going to be equal to 110 degrees. Alright, and so we don't need any of these other angles in order to solve the triangle, which means that we're good to go. Let's use, since we're using Q as our setup, Q squared is going to be equal to R squared plus P squared, subtract 2 times R times P, cosine 110 degrees. Okay, and we're looking for, remember, PR, and so that is Q, but I'm just going to continue calling it Q squared in my example here. So we have 1.7 squared plus 3.1 squared minus 2 times 1.7 times 3.1 cosine 110. Okay, and so from here we can just plug whatever we have into our calculator. It's 1.7 squared times 3.1 squared, and we're going to subtract from those answers 2 times 1.7 times 3.1 cosine 110, and we're going to get an answer of 31. And hold on a second. 1.7 squared. 1.7, 2 times 1.7 times 3.1. Yep, looks good. Times cosine 110 degrees. So we get an answer, Q squared squared is equal to 31.37. I'm just going to leave it like this, my answer, but remember, if we're looking for Q, we have to take the square root of this. Okay, so if we take the square root of that, we're going to answer a 5.6. And to the nearest tenth, we are going to get 6.0 centimeters. Okay, this next question, class example number 4. Let me straighten that up there. Okay, so Bellevue is 30 kilometers north of Ayr, and Churchville is 18 kilometers northwest of Ayr. Calculate the distance between Bellevue and Churchill to the nearest kilometer. Okay, so remember we're working with triangles. If you're reading this, you're like, whoa, how do you know what this diagram looks like? Since this is trigonometry, I think it's safe to assume that we are using a triangle. Okay, so if I have Bellevue, or first of all, if I have Bellevue is 30 kilometers north of Ayr. If you took physics, then you know that when we're talking about vectors and we're talking about direction, especially, that we set things up, and if we're talking about north, we usually put north on the top of our page. So this is going to be Bellevue, which is north of Ayr, by 30 kilometers. And so if I know that Bellevue is north of Ayr, then I know that Ayr is south of Bellevue. So I'm going to put Ayr down here. And then I know that Churchville is 18 kilometers northwest of Ayr. So if I go north and west, then that's going to be where Churchville is. So Churchville is 18 kilometers away. And, coincidentally, ABC, we have an ABC triangle that is made. And so if this is on a, on some sort of compass or vector setup, then this is going to be going like this. And if we're going straight up and then west, then this is going to be exactly 45 degrees. All right, and so we have side A, we have side B. I'll put these in brackets so we don't get confused, and then we have side C directly across. Now, the distance we're looking for is side A over here. And so if we're looking for side A, then we can use that first variation of our cosine law, which is a squared is equal to b squared plus c squared minus 2bc cosine A. All right, and so then let's plug in what we have. We have b is equal to 18 squared plus c, which is equal to 30 squared, minus 2 times 18 times 30 cosine 45. Excuse me. Okay, if you plug this in your calculator, you're going to get an answer of 460.32, and there's some decimal places there. And I'm going to, in my answer, in my calculator, I'm going to use all my decimal places. I'm not going to put the square root of 460.32. And when I do that, when I take the square root of this, so if I take the square root of that and the square root of that, I'm going to get 21.45. And so we're just going to say that distance from Churchill to Bellevue is equal to 21 kilometers. Okay, so again, we've used the cosine law to solve that question. Now let's look at the alternative form of the cosine law. All right, so the equation a squared plus is equal to b squared plus c squared minus 2bc cosine A is the cosine law. But this can be arranged to the form cosine A is equal to b squared plus c squared minus a squared over 2bc. And we would just rearrange that algebraically. And so if I wanted to rearrange this, then using this first variation of my cosine law, I would just bring all of this to the other side. So I'd have to add it to the other side. And if I were to add it to the other side, I would be left with 2bc cosine a plus a squared is equal to b squared plus c squared. And then I would have to get rid of this and this in order to isolate my cosine a. And so if I'm looking for the angle, this is what I would do. So cosine a is equal to b squared plus c squared. If I have positive a, it's going to be I'm going to subtract it on this side, and then if I have cosine a multiplied by 2bc, then I'll divide by 2bc. And that will give me my second variation, which is just I guess this is my third variation of my cosine law down here. So the reason we would do this is if we're looking for an angle. Okay, so if I'm looking for cosine b down here, then in order to find cosine b, I would rearrange that second variation of the equation, which would leave me with c squared plus a squared minus b squared divided by 2ca. So that's if I'm looking for angle b. If I'm looking for angle c, then that's going to be b squared plus c squared minus a squared divided by 2bc. Okay, and so this would be a rearrangement of the third variation, or the second variation of the cosine law when we're looking for side C. Alright, so these are things that you need to be able to do, and remember you're doing so just by rebalancing your equation of your initial cosine laws that you're looking for. Okay, so these are really important that you know how to do. Alright, so determine the largest angle in triangle ABC if A is equal to 14.7, B is equal to 8.9, and C is equal to 12.6. Alright, so let me just straighten this up here. There we go. Okay, so we again have a triangle ABC. I'll call it ABC. Alright, so I know that side A is 14.7, and so if I have angle A here, then side A is going to be right here, and that's 14.7. I know that side B is equal to 8.9, and again, B is directly across from angle B, and then I have my last side C, which is 12.6. Okay, so notice that we're not given any of the angles, and so that's what we're looking for. We're looking for the largest angle in this case. Alright, and so if you're looking for the largest angle, you might, I don't know, you might need to we will for sure need to redraw this triangle. So I know that this is the longest side, which was 14. I know that this is the smallest side, that was 8.9, and this side I know has to be, it has to be shorter than this length. And so this would end up giving me the largest angle. So what I'm looking for then is angle A. Alright, now again, you would know this is the largest angle if you were to redraw this using, exact proportions. But let's ignore this little triangle for now. So I'm looking for angle A, which means I'm looking for cos A, and that is equal to B squared plus C squared minus A squared. And again, eventually you'll get better at recognizing which equation to use for which angle, but if not, then you can always just manipulate the part of the angle you need. And so B squared was 8.9 squared plus 12.6 squared minus 14.7 squared. That's divided by 2, 8.9 times 12.6. Alright, so that is going to give you, well, let's type this in your calculator. Alright, and so I know it's always a temptation that you feel like if you type everything in your calculator at once, you're doing less work. I know that's what it feels like. But when you have something like this, it's really easy when there's a lot of numbers and there's a lot of different operations you need to use. I know it can be you shouldn't always do that just because you can make an error somewhere, like a really easy error to make. And so I'm going to do this in a few different steps. Okay, so notice I'm using brackets first of all, right? And I just want to make sure that all parts of my equation are separated. So cosine A is equal to 21.88 divided by, so I'm going to divide this. Well, I won't divide it yet. 2 times 8.9 times 12.6. Divide by 224.28. This 21.8 divided by that is going to be 0.0975. So cosine A is equal to 0.09755 . Okay. Now I'm looking for angle A, and so in order to solve for angle A, I'm going to need to take the inverse of the ratio that I just found. So cosine inverse cosine of my previous answer, which is 0.0975556, is going to give me 84 to the nearest angle. Angle A is going to be 84 degrees. Okay, so that's my final answer. Alright, I'm just going to pause here and eat my breakfast. In this last example, 2 ships set sail from port P, heading in different directions. So here's port P. The first ship sails 7 kilometers to R, and the second ship sails 8 kilometers to Q. Okay, if the distance between R and Q is 13 kilometers, determine the angle between the directions of the 2 ships. So we are looking for this angle right here. Alright, so if we're looking for angle P, then we're going to be using the variation where we're solving for P. And so the equation would look like cosine P is equal to Q squared plus R squared minus P squared divided by 2 times QR. Alright, so I'll plug in the information that I have. 7 squared plus 8 squared minus 13 squared divided by 2 times 13, or not 13, times 7 times 8. Okay, so if I were to put this in my calculator, I'm going to get an answer of, let's see here, 7 squared plus 8 squared minus 13 squared divided by 2 times 7 times 8. Okay, so I get an answer of -1/2. Now remember, if we were to use this ratio, so cosine of negative, when our ratio is -1/2, remember that gives us a reference angle of 60 degrees. And because it's negative, it would be in the, it could either be in the third or the second quadrant. And so we would subtract that angle from the reference angle from 180 degrees minus 60 degrees, and we would get an answer of 120 degrees. So that's that angle is 120 degrees. But we could also put this in our calculator. Cosine of -0.5 gives us 120 degrees. So that is our final answer.